Hi, I'm Miss Hall, and this is Lesson 20, Writing a Quadratic Function in Vertex Form and Modeling. Recall that the vertex form of a quadratic function is y equals a times x minus h squared plus k, where h comma k is the vertex of the graph of the function. You can write a quadratic function in vertex form by completing the square. Example 5. Writing a quadratic function in vertex form. Write y equals x squared minus 12x plus 18 in vertex form, then identify the vertex. Okay, so this quadratic right now is in standard form. To get it in vertex form, let's go y equals, we're going to isolate the x squared plus bx value, x squared minus 12x, leave a space, plus 18. You remember from the previous lesson, to complete the square, we take b divided by 2 and square it and add that to both sides. So half of negative 12 is negative 6. Negative 6 squared is positive 36. And to keep an equation balanced, what we do to one side, we must do to the other. So we need to add 36 to both sides. We have y plus 36 equals, I can now rewrite this as x minus 6 squared plus 18. Now subtract the 36, so I've got that y equals x minus 6 squared minus 18, right? 18 minus 36. Here is the function in vertex form, and the vertex is h comma k. The vertex h is 6 and k is negative 18. Remember that h is what's subtracted, x minus, there's the h value, and then k is what's at the end, negative 18. Example 6, modeling with mathematics. The height y in feet of a baseball t seconds after it is hit can be modeled by the function y equals negative 16t squared plus 96t plus 3. Find the maximum height of the baseball. How long does the ball take to hit the ground? We're given the equation in standard form, so we're first going to convert it to vertex form and then easily identify the vertex, which will include the maximum height of the ball. Then for b, we're going to set y equal to 0 to solve for the time it takes the ball to get to a height of 0. Keep in mind, we complete the square when we have the form x squared plus bx, where the coefficient of this x squared is 1. Something new we're going to have to take into account here is we need to get rid of that negative 16. So what we're going to do is I'll rewrite this as y equals, I'm going to take the GCF out of the first two terms, that is negative 16, which leaves me with t squared minus 6t, gives me room to complete the square, plus 3. Okay, so that's new. Taking the GCF out so that I have a coefficient of 1 in front of the quadratic term. Now I will take negative 6 divided by 2 squared. Half of negative 6 is negative 3, squared is positive 9. So I add 9 to the right side, and to the left side I don't add 9. Because I have to remember that I took out a GCF of negative 16. So this is really negative 16 times 9 that I'm adding to both sides. I'll rewrite this as y minus 144. That's the product of negative 16 and 9. Then we have negative 16 times t minus 3 squared plus 3. Get y by itself. This is t minus 3 squared plus 147. So now I have the equation in vertex form. I can identify the vertex. The vertex is 3 and 147. So the question is, find the maximum height of the baseball. The maximum height is the y value, so this is the maximum height, 147 feet. The x value, if you wanted to label it, is that it takes 3 seconds to reach the maximum height of 147 feet. Now part B, how long does it take the ball to hit the ground? So what we can do is we can set y equal to 0, get negative 16 times t minus 3 squared plus 147. We'll move the 147 over, get negative 147 equals negative 16 times t minus 3 squared. Divide both sides by negative 16, which will get negative 147 over negative 16 equals t minus 3 squared. Now we can take the square root of both sides. When we are adding the square root symbol, we put plus or minus in the front. So t minus 3 equals plus or minus the square root of 147 over 16. That radicals over everything. So t is equal to 3 plus or minus the square root of 147 over 16. And when you add or subtract these values, you're going to get that t is equal to approximately, it's negative 0.03 seconds and 6 seconds. We're going to reject the negative solution because it's a real world problem. Negative 0.03 seconds doesn't make sense. So our answer is going to be it takes 6 seconds for the ball to hit the ground. And that makes sense to me because the vertex is at 3 seconds. And so I'm kind of picturing this ball going up and then down where the vertex is almost in the middle. Makes me think that the y-intercept is not 0, 0, right? It's 0, 3, but it's close. But the answer to part B is 6 seconds. Okay, I'm going to convert from standard form to vertex form. So I'll rewrite this as y equals x squared minus 22x, leave some space, plus 16. And I'll take half of negative 22 and square it, which is negative 11 squared is positive 121. You rewrite y plus 121 equals x minus 11 squared plus 16. Subtract 121 from both sides and I get x minus 11 squared minus 105. Therefore, the vertex here is 11, negative 105.